Welcome back to chemistry. This is part 5. I'm Dr. Rhonda Cofelt. In this section, we're going to talk about conversion factors and dimensional analysis, which is at the heart of chemistry and a lot of other things like physics and engineering. So we're going to use conversion factors to use unit conversions, and then we're going to apply dimensional analysis to solve problems. So a conversion factor, if I can find my pen, the conversion factor is basically a fraction. So we use equivalents, okay? So something equaling something else is called an equivalent. So 1 inch is equal to or equivalent to 2.54 centimeters. They are the same thing. So when we write them as a conversion factor, we write them as a fraction, where you can have 1 inch over 2.54 centimeters, or you could have upside down 2.54 centimeters in 1 inch. And the reason, because since these are equal to each other, 1 divided by the other equals 1. Okay, so that's why we can use these conversion factors in order to solve problems. So when we're using those, if it's going to be 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch, that depends on what you need to get rid of, what units you're getting rid of as you're working this dimensional analysis problem. What do I mean? Okay, we're going to take 12 inches and we're going to convert that to centimeters. Okay, so if I put centimeters on top and inches on the bottom, that gives us inches over inches, and that is to say anything divided by itself is 1. So that gets rid of inches and leaves us with centimeters, which is what we want in our final answer. So the conversion factors, we can use them. We start with what we can measure, okay? And then we use conversion factors to convert them to whatever units we want. So in this case, our conversion factor, which was the 2.54 centimeters per 1 inch, we used that to get to where we were going to from inches to centimeters. So in dimensional analysis, let's say that we wanted to get it to meters, okay? So like I know 2.54 centimeters in an inch. That's my go-to for getting from English system to metric system in chemistry. It's just easy for me to remember for whatever reason. So if I get it from the English inch system to the centimeters, which is the metric system, then I can use that metric unit to get to whatever other metric unit I need. For example, inches times 2.54 centimeters over inches gets rid of inches, leaves me with centimeters. But I want meters this time, so then I'm going to put another conversion factor here that gets me from centimeters to meters. And there's 100 centimeters in 1 meter, and so that gives me 0.3048 meters. Remember, we looked at the metric system and its multiples of 10. So once I get to the metric system, it's pretty easy to convert it the rest of the way. So the Food and Drug Administration, FDA, recommends dietary sodium to be no more than 2,400 milligrams per day. In this problem, I'm telling you that the 2,400 has 4 significant figures. So that's what you're going to use when you're looking at the calculation. So it wants to know what is the mass in pounds if 1 pound is equal to 453.6 grams. So in this case, we have like a 2-step problem going on. In the first step, we are going to convert the 2,400 milligrams to grams, because my other conversion that I have is grams to pounds. So I need to get milligrams to grams, and there's 1,000 milligrams in 1 gram. And then I can multiply it by, and that gets rid of milligrams. And then I can multiply it by my conversion factor. I need to get rid of grams, leave me with pounds. And so that's how I know which one goes on top. And then my answer is in pounds. So you're going to be getting rid of those units as you go through. So here's your practice. You've got actually 2 practices to do on this one. Okay? Now, this one is important because this requires us to raise units to a certain power as well as numbers to a certain power. So average adult has 5.2 liters of blood. What is the volume of blood in cubic meters? Well, we know 1 liter equals 1,000 milliliters or 1,000 cubic centimeters. 1 centimeter equals 1 times 10 to the minus 2 meters, or 100th of a meter. So when we raise it to a power, make sure that in that conversion factor that you're raising those units as well. So since I'm going to go liters to cubic centimeters, okay, which I can do easily, I'm going to go from cubic centimeters to cubic meters. Now, what you keep in mind is you're going to use that same conversion factor, 1 centimeter is the same as 0.01 meters, right? Or another way of saying that is 100 centimeters in 1 meter. I tend to like to do the big numbers. I don't know, it's just I'm more comfortable with it. But either way, and there's 1 centimeter and 10 to the minus 2 meters. So I know that centimeters has to go on the bottom because it's going to be canceling that. But what I have to remember is it's cubic centimeters to cubic meters. So this whole thing is cubed. That means the 1 times 10 to the minus 2 is cubed, and the meters is going to be cubed. So you end up with 5.2 times 10 to the minus 3. Check this in your calculator and make sure that you get this, that you're putting this information right here, especially in the right place. And your units will end up being cubic meters. So you use the same exact conversion, 100 centimeters in 1 meter, but in this case, you're going to have to cube everything in order to get to your cubic meters. So that's really the only difference in those. So here's one for you to try to see if you can figure out the cubic centimeters to cubic meters. And this one, you're also changing grams to kilograms. So do one at a time. I do the grams to kilograms first, and then you can do the cubic centimeters to meters cubed. All right. That's it for Chapter 1. Great job.